Hello, let's continue with our top interview questions, 150 of them. We've done 13 so far, 9%, okay. So I'm trying to do one per day. Sometimes it feels tough to continue one per day. Things happen in life, but I'll just do my best to continue. All right, gas station. So I think this means that I have done this before. Okay, so apparently I did it last year. Okay, a year ago. So I don't remember anything about this at all. So let's redo it. There are N gas stations along the circular route. Oh no. Oh, this is one of those tricky ones. Like either you get it or you don't. I don't remember this. Okay. Amount of gas at ith station is gas. You have a car with unlimited gas tank, and then okay, there is a cost. The cost is only from current one to next one. You begin the journey with an empty tank at one of the gas stations, any one of them. Given two integer arrays, gas and cost, return the starting gas station's index if you can travel around the circuit once in the clockwise direction. Otherwise, return -1. Okay, if there is a solution, it's unique. Seems pretty complicated. And it also seems like I need some pen and paper to draw this. Or no, I will just try to write it here. We cannot draw a circle here, but we will try. Gas 1, 2, 3, 4, 5, which means here we have 1 unit of gas. Now we have 2 units of gas, and the cost from I'm getting no messages. So cost of starting from gas station, the first one, the cost is 3. And we only have 1, so that does not work. Okay, what if we start at this one? That doesn't work either. Am I missing something? No, okay. Next one, we can get 3 units of gas, but it needs 5 to go to the next station, so that doesn't work either. Okay, 4. Okay, now we're talking. We are getting 4 and we are spending 1, so we will have 3 left when we are at the next station. We have 3 left, and then we get 5, so we have 8. And we spend 2, so we have 6 left. And now we are getting 1, we have 7, we spend 3, we have 4 left. We get 2, we have 6. We spend 4, we have even 2 left. And then 2 plus 3, we have 5, and we spend all 5 to go around. Do we need to go travel around the circuit once, clockwise direction, so like this, going forward? Okay, so if we start here, we need to go all the way for 5, 1, 2, 3, and then return to 4. I guess that's what it means. What it means, yes, okay. I'll put 3, start at station 3, index 3. Right, so that's the process. Now let's see this. 1, 3, that doesn't work. 3, 4, that doesn't work. So what if we start at 4? We spend 3, we have 1 left. Okay, we have 3, we spend 3, and then we have 3, we need to spend 4 to go to the next one to complete the circle, so that doesn't work. That gives output -1. Okay. Guess out and cost have the same lengths. They're all positive and bounded. Alright. We have some ferries or boats coming, I guess. That's the sound. Okay. So the brute force solution is to try all of them and just go a full circle and see if it works. If it doesn't work, we break right away and go to the next one. Is there any better solution? Not sure if there's any better solution. How about we just code the brute force solution, and then if it's very inefficient, we will try to improve. It doesn't say anything about time or space complexity requirements, so let's try to just code the brute force. We start with that. Okay, so let's start with the first one and try all of them. I in range. So we are starting from the first one. And for each try, we need to go through the entire array again. First thing I want to check is if guess I is smaller than cost I, then it simply doesn't work. We could just continue skip. If it's at least the same, then we know at least we can get to the next one. We need a variable that's basically the amount of gas that we have. So let's start with 0. Empty tank. So continue, and this is where it starts. 4 is bigger than 1, so now we're going with 2 for loops that will be quadratic time. Okay, for k in range, let's use j. For j in range I, it wants to start from I, and well, it wants to start from this but actually go all the way to this. I to I plus minus, so this will be index 3, length is 5, so 8 modulo 5 will give us 3, so -1, that's where it's gonna stop. So this actually is gonna stop there, right? That's good. So obviously we need this one to be modular when we do take the index. Okay. So that should take care of it. If it's 8, length is 5, then that'll give us 3. So, okay, so we are at 4. Amount is now 4. Oh, J. Minus cost. So that's what we have when we. So 4 minus 1, we have 3 left. We go to the next station. Next station. Amount is 3. We are plus 5 minus 2 again, so that's still good. So at any point, so we need to handle when this amount goes to 0 or negative. So this is still good. So, but in this example, it actually does not go to negative. It goes to exactly 0 when it's back. So, oh wait, I'm just thinking about something. See, if the sum of this, if the sum of all the gas is smaller than the sum of the cost, then it will not be able to complete the circuit. Right? Yeah. So in Python, can't we do just thumb? That must be a function. It's okay. Can I just do sum of gas is smaller than sum of cost, then we just return -1. Okay. Let's continue with this. So well, this is not, it's probably not the best example. What if we started at 5? Okay, that would be more interesting. Okay, because that we will actually run into the negative. So if we started at this index, so we have 5 minus 2, we have 3 left. Now we have 4 minus 3, we have 1 left. And here we have 3, but the cost is 4. So that's where it fails. So after this, the amount is now negative. If amount, so negative definitely does not work. What about 0? If we have 0 left, what does this mean? See, amount, current gas minus current cost. Okay, if it is 0, then we are standing at the next station, so that actually is fine, because at the next station we will do another gas minus cost. Okay, so if amount is negative, that's when we know that this start index does not work, and we want to break out of this for loop. Is that what it, Python break for loop? And if it does work, since it says it is guaranteed to be unique, then if it does work, then we can return strange. So what about the last one? If it's at the last one, when it's at the last one, when j is okay, so here I is 3. We're starting at index 3, and j will go all the way for 5, 1, 2, 3. So j will go all the way to I minus 1. So once we reach, if j is equal to I minus 1 and oh wait, one sec, let's see. Does it, you go, last one is this. Add minus okay, yeah. So that means it is able to reach the start index. So if it's able to reach the start index, then j is equal to minus 1. That means we have found the start index to be I. Otherwise, we return minus 1. But we essentially, that's the minus 1 case, and this is just finding it. But we still need a return, as far as I know. Oh, forgot to set the timer again. No, it does not work. Alright, let's see. Output is minus 1. Well, this gives some 15. What about this? This is also 15, so that's not returning from that. Alright, we shall go over our loop and see what's wrong. Okay, so start from the first one. 5, 4, that works. We have 1 left. And 2, 4, that does not work. Let's just see why this does not work. Okay, so start from I equals to 4. Okay, so that is bigger. We will set j to start from 4, and j will go from 4 to 9. But this is exclusive, so 4 to 8. 4, 5, 6, 7, 8. Okay, so 4, after this step, it will be 4, 0, 1, 2, 3. Okay, so amount is 4. Oh, I see. This amount needs to be reset for each time we retry a new start index. It is not working. Exit 1. Okay. 0. So what do we have here? 3, 1. We have 2 left. Okay, so that works. So why doesn't my code work? Start from 0. Okay. 0, 0. J goes from 0 to 0, 1, 2. That's what J is gonna be. So J is gonna be 0, 1, 2. Amount is here 3 minus 1, so 2. Amount is now 2. J is 0 and I is 0, so I see. Okay, and then we go to 1. So then 3, 2, we have 1 left. Amount is now 1. I see, the problem is I here is 0, so this is minus 1. It's never gonna be equal to minus 1. Minus 1 if J is so J will be 2. What about if J plus I equals the length of this? Let's see, if J is 2, I is 3. What if J is 1, I is 2? Oh, that definitely does not work. So what we need is what we need is if J plus 1 modulo length of this. So if J is 2 plus 1, 3, modulo 3, if that is equal to I. So that's what we need. So if J is here, the next one, if the next one modulo length is I, that's when it's full circle. Now it's running very slow. Oh no. Oh, time limit exceeded. There we go. This solution is not efficient enough. Oh, bummer. Well, it is the brute force solution, so I guess that's expected. At least we have a solution that seems to be working. It's already been 20 minutes. Alright, let's see. Gas station. So we have a bunch of 0. Is there anything we can do that cuts some part of the operations? For I, so what happens when we have all these zeros? The amount will be 0 and it will continue to run because it's not breaking anywhere. I see. But actually when we have 0 gas and it costs 0 to get to the next one, well, it does go to the next one, so we can't break from that. It does have to go to the next one. Okay, we need to think of another solution. Let me try. Let me try something here. I don't know if this is gonna lead to anything, but let me just try this. What about this? Three. So we see it's minus, we go to the next one, go to the next one. Now we see 3. Okay, so then we do 6. What if we just do this and we add the next one until we reach negative? I mean, it's essentially the same logic. Would that be any different in complexity? That is still 2 for loops. So that's 2 for loops. Is there any way to do this without using 2 for loops? Oh, I can't seem to think of something. Okay. I think I need more examples to figure this out. Okay. What if we had A still has to add up to at least 0. And I'm not sure if this guarantees only one solution, one unique solution. But this should. Okay, let's see. So after first station, we're left with -1. So that doesn't work. Okay, what if we start from here? After first station, we're left with 1. That doesn't work. That doesn't work. So what about this? Okay, that works. That works. Yes, we have 3, we have 2, we have 4, and then yeah, so this works. So this start index works. What about this one? That doesn't work, but this works as well. Yeah, 4. Yeah, so this is not unique. But even when I'm looking at this, I'm still doing the same way I'm doing here. I'm trying out all of them one by one. I will skip if it's negative, and I will continue until the amount is negative. Is there really a solution without using 2 for loops? I mean, the increments here would be so does that tell us anything? No. There are 6 test cases not passed. Ton of 0. Okay. The cost is a lot of 0 as well. So we have these zeros. Could we just skip some stuff if we had zeros? I mean, even if we skip the zeros, when we do get to the one that's non-zero, we still have to calculate the entire circle. Okay, but at least we skipped calculating that entire circle for those 0 entries. Okay, let's see. If gas 0 and cost is also 0, then we also skip 2. Wait, why is this not the correct syntax? Oh, I see. This is not gonna pass. And then this is not gonna pass because it's still running. Okay, if this doesn't work, oh, I see. So the zeros are good now. Now we have a bunch of ones and zeros. Okay, we have tons of 1 and then 1,000. And what do we have here? Oh, I see. Cost 10,000. gas. $1,000 and $10,000. So what do we do in this case? So in general, the cases that's returning time limit exceeded are those that have repetitive inputs in the gas and cost arrays. So it is very inefficient to be going over them in each loop again and again because they just have similar values. They're just unnecessarily calculating these same values. How can we avoid that? I can't seem to think of anything. Okay, let's see. Supposed to be greedy. I have not come up with a greedy solution. This is not greedy. This is brute force. A greedy solution. Greedy. Alright, it's been 43 minutes, so I would have failed this anyways. So I'll just give up here. And alright, so this did not meet the time requirement because it's 2 for loops, it's quadratic time. What about space is constant. So quadratic time, constant space, not good. Let's have a quick look at other solutions. And then it's time for dinner. An explanation that ever exists till now. Probably meant never. Quadratic constant, yes. Now how can we do this in linear time? Car start at 0, it's able to make at least 3 gas stations. after trying to make it at the fourth gas station, it ran out of gas. Oh. So if we start from here and we filled here, that also means that if we started from there, it would also fill, because the reason that we are even able to go from this one to that one is because this is at least positive or 0. If it's negative, it wouldn't even be able to go here. So okay, let's look at this again. So if we start here and imagine we can reach this one, this one, this one, but we're not able to reach that one, that means if we had started here, we would not be able to reach that one either, because this part has to be 0 or positive. And if we remove a positive part or a 0 part, then the gas left will just be even smaller or the same, so it won't be able to go any step further anyways. So when we realize that it fills here, there's no point in trying from that and that again, and or that. So we can just start trying from the next gas station. Okay, so what does that mean for my code here? So once I realize that the amount is 0, we do not want to try with the next I, we want to try with the next index. I is now j plus 1, because it was standing at j. The amount is, so it was, okay, let's say it's standing at j. The amount is gas minus cost. If this is negative, that's where negative happens, so we want to try with the next one as start index instead. And then we break out of this and then we continue. Okay. Oh no, still looks like it's not gonna. Oh no. Oh, I was so hopeful. Why is that? Okay. So total surplus. what is this total surplus and surplus? What's the difference? So surplus will be reset when we see negative. Because we're restarting our tank. Oh, total surplus, that's just basically calculating this part. Okay. So surplus, yeah, if it's negative, then we're not able to reach it, otherwise it's start. Okay, so surplus, that's our tank. So apparently all we need to do is to just do this, and if it's 0, wait, start is I-1. I need more time to think about this, because we are actually oh wait, oh wait, so J, so that's the start. Okay, so this is the start, and so that's the start. J. I wonder why this is not working though. So I is the start, and J goes from I and loops around. When it's negative, we wanna update the start to be the next one, and we break. Shouldn't this break out of this for loop, and then we'll just skip everything in between? Why is it not working? Apparently, we're only looping this once instead of trying to start from each place. I see. Okay. So it only starts from the first one, and if we reach some point that it is not negative, that means that everything here doesn't work anyways. So there's no use in trying now, we just try with the next one. But how is this making sure that it goes all the way around? Because it doesn't go all the way around. So I guess the only thing that it's checking is just this total sum. So as long as the total sum is positive, okay, so if the total sum is positive, then we know there is a solution and it's unique. And where does that start? So if we do this and it doesn't work, then we know it doesn't start from any of those. We try this. Let's say if there are some more here and it does work, does it mean that we do not have to actually go loop around and calculate that again? Because that part already works and we know the total sum works. So then it simply works. Is there any case that we can start from here, go all the way to the end, and it does not work? What if, okay, so that case would be if total sum is positive, so we do have a solution, but the solution doesn't start from this one. The start index is not this one, it's something else. Would this still give this positive all the way then? If that is not the right start. So that's what I'm thinking about. Okay, I guess. So if we start from here and let's say it goes all the way to the end and it's positive 5, and we know that the entire thing is also positive, so there is a solution. So the question is, does that mean that this is the start index that we're looking for? Or is it possible that this goes to the end all the way, being positive, but it wouldn't be able to actually continue all the way around? Is that possible? I mean, the total sum being positive doesn't mean that it will work. But the question is, if this is positive to the end, does that mean that the rest of this loop will also work. Okay, I'm not actually seeing the explanation as to exactly why, if we get positive starting from here all the way and then the entire is also positive, that means when we get there, the rest of this will be able to complete the trip. Because what if one of this part becomes negative? Let's say we had positive 5 after going all the way, then we come back here. So if this to the end is positive 5, then let's say this first part is -4. So it should be able to complete the trip. Now, this -4, could it be possible that we're at positive 5 in the end, but the first one, let's say it's -8? Is that possible? I guess what I need to prove is that that is not possible, because otherwise this algorithm wouldn't work. Okay, now it's been over an hour, so I really need to eat something. I will continue to think about this afterwards. Maybe I will make another video if I do come up with some kind of mathematical proof. Alright. Okay, very interesting question. Okay, I will see you in the next one. Happy Friday, everyone.